The second method, so in the second method, a flag byte means we are going to use a specific character to indicate the beginning of the frame and end of the frame. Specific character is being used. As a result, the problem what we have faced in the byte count method will not be there in this. Okay, whatever problem we have encountered in the byte count method, that problem will not be there in this. That is being taken care because a specific character we are going to use to indicate the beginning of the frame and ending of the frame. So that is the second method, flag bytes with byte stuffing method. Okay, but here, so earlier days, so to indicate the beginning of the frame, a particular character is used, ending is a different character is used. So same character is not used earlier days, but later because of the errors or problems or difficulty, so same character they used to use both to indicate the beginning and ending of the frames. Okay, so same character is being used as indicating for beginning and ending. So as a result, what is happening, even though if the receiver is lost the synchronization, that means the speed mismatch, but still there is no problem of identifying the ending of the frame because a specific character is being used for indication of ending of the character, ending of the frame. So that is why even though the receiver and transmitter doesn't agree for a common speed, flow control, if it is violated little, but still no problem. Okay, then receiver is able to identify the end of frame with that specific character. So it will wait for the specific character to receive. The moment it receives that specific character, which is being indicated as delimiter or end of the frame, so it can easily identify that is the end of the frame. Okay, depending on the type of protocol that is being used. So in some cases, only one specific character is used to indicate beginning and ending. That means, suppose I am using a specific character at this point. This specific character will indicate end of this frame, and this is being used as beginning of the next frame. Okay, without any problems. The same character will indicate ending of the previous and beginning of the next. So that is how it is. And whereas some protocols, they may be using two specific characters. When two specific characters are used, this one is being indicating as end of this previous frame, and this will be used as beginning of the next frame. So that is how, even if two specific characters are being used, the first one indicates end of the current frame, the second one indicates the beginning of the next frame. That is how it is easy for us to identify beginning and ending of the frames with the help of characters like this, specific characters like this. So that is a biggest advantage in this, but even this may be having problems. Okay, so if you see the diagram, now I want to use, these are the characters I want to send. A, here the flag is nothing but the specific character that we are using to indicate the beginning of the frame and ending of the frame. Okay, ending of the frame, this is the ending of the frame, flag byte. This flag byte is indicating beginning of the frame. So after this flag byte, my first frame starts, and the moment I encounter the flag byte, my frame over, frame is ending. Okay, as of this, no problem. But the same flag byte, if it is part of my data somewhere in this, okay, there is no guarantee that I will not use this as my character, regular data. So any character can be part of my regular data. So as a result, now if it happens to be the flag byte is part of the data, in that case, maybe the receiver is going to misunderstand that the moment that flag byte is encountered in the part of the data, then the receiver may think that this is the end of the frame. This will be the end of the frame. So after this may be the beginning of the next frame. So it is going to misunderstand or misinterpret. The receiver is going to misinterpret that by encountering the flag byte which is being used as delimiter or indicating character for the beginning and ending of the character, ending of the frame. If the same character happens to be part of the network, part of the data, then there is a problem. So to rectify this problem, what will be done is an escape character is being added along with the flag byte in the regular data part, that is in this area. So as a result, the moment receiver encounters this escape character with flag byte, so receiver will think that okay, this is part of the data. So escape character is accompanying the flag byte means, so this is part of the data. This is not the end of the frame. That is how the receiver will understand. Then completely it is going to receive. Wherever it is receiving only one specific character or flag byte, then he is going to understand that it is the end of the frame. Okay, that is how this problem can be taken care. Suppose I am using the escape character as part of my data, then again this may be treated as the escape character or flag byte. Sometimes escape character may be used as the flag byte. Okay, so because most of the case escape character is not being used in the regular data, very rarely it is being used. So maybe people will think that let us use escape character as the indication of end of the frame or beginning of the frame. If it happens to be escape character is part of my data, then so instead of sending one escape character, now additional escape character is being included along with this. Now these two adjacent escape characters indicates one escape character is part of the data. So at the receiving time one is removed and remaining is taken as part of the data. Same way here also. A flag byte is attaching with the escape character means part of the data. So to avoid the misunderstanding, the escape character is being attached with the flag byte. So at the receiving end, this is being removed and processed. Okay, that is how. But again, I may be using in my data escape character and flag byte, both are there part of data. Suppose if escape character and flag byte both are there part of the data, then I have to use one escape character for the flag byte and one escape character for the other escape character. I have to attach to avoid the ambiguity. Okay, to avoid the ambiguity. Otherwise, what happens is if I am sending this escape character and flag byte as it is, a receiver may think that to avoid the misunderstanding that this flag byte indicates the end of the frame, this is being added. Receiver may be thinking that way, then this will be removed, only the flag byte will be used as part of the data at the receiving part like this. Okay, the receiver may be thinking that this is the data but they have sent this, if this is being sent as it is. So this will be removed and remaining part will be taken as data part. That means we are going to get error because actually this is part of the data. So as a result, so one escape character for the flag byte and one escape character for this escape character is to be added before transmission. Then the receiver will understand when three escape character and flag byte is means, so two escape characters are being added to avoid the misunderstanding of this as part of either frame ending or only one character is part of data. To avoid that misunderstanding, these two are used. If at all both of them are escape characters which has to be part of data, then two additional escape characters are to be added. So this is how if any escape character or flag byte is appeared as part of the data in the data field, so to avoid to misunderstanding that as end of the frame, So the additional escape characters are being attached or added at that place, okay, for avoiding the confusion. So this is what is being used in the flag byte method. But here also there is a problem. Okay, here also there is a problem. So whatever we have discussed, that is about all these points. Okay. So this what we are calling is the byte stuffing. But thing is, so unnecessarily this is being increasing the frame size. Unnecessarily when you are using the escape characters or flag bytes part of the data, okay, so unnecessarily it is increasing the frame size. So that is why even this particular technique is not much preferred in the networks. So this method is called byte stuffing because we are adding additional byte in place adjacent to the escape character or the flag byte to avoid misunderstanding at the receiver side. So that insertion of this additional escape character to prevent deletion of that escape character from the data part at the receiving. Okay, so that particular method what we are calling is byte stuffing or character stuffing. Okay, so as it is leading to unnecessarily long frame size, so more number of frames, that is why this method is also not much preferred. Okay, so that is about this. And another, because one more disadvantage with this is whatever this method we are using is only for 8-bit characters. We are keeping the mind every character size is of 8 bits. So accordingly we are using this. Okay, even though if the frame size increases, but still the method is no problem. But thing is, sometimes we may be using a code other than our ASCII code or extended BCD code. Suppose a Unicode is being used, which is having the character size is 16-bit. Then the problem comes. Okay, then there is going to be a problem. So because of that, this particular method is not preferred. So bit stuffing method is being alternate for this. That bit stuffing is, in case of bit stuffing, okay, additional bits are being, instead of character is being added, now a bit is being added. So and you can have the size of the character can be variable bits without any problem. So that is the advantage of the bit stuffing compared to the byte stuffing or character stuffing. Because so in case of byte stuffing, all characters must be uniform size. So if people are using other than uniform size, that is 8-bit characters, if somebody goes for the 16-bit characters, then the problem comes. So because of that, instead of using the flag byte or byte stuffing method, so flag bits method or bit stuffing method is being used. Okay, so in the bit stuffing method, how it is being taken care is, so the same way at the one particular one, this is being used as the flag byte, means here it is 7 and E. This is a byte 0, 6, 1s and 0 is used as the flag byte, means that is going to be used as indication for beginning of the frame or ending of the frame. The same we are going to use even the bit stuffing method. So with this, what we can be do is, now we can easily identify that the data, the ending of the frame. But here also there is every possibility of that the multiple ones may be part of the data. If that is the case, so one method used in this is after every 5 consecutive ones, a 0 is inserted. Okay, in this particular procedure, after every 5 consecutive ones, a 0 is inserted. So now, so 6 consecutive ones are there. after 5 consecutive ones, a 0 is inserted between this. Okay, right from right side, between first and second one, 2 ones, a 0 is inserted. That is being sent. And at the receiving end, after 5 ones, if there is a 0 is there, will be removed. Okay, destuff. That is the meaning of bit stuffing method is used. Okay, similar to bytes of, instead of inserting 8-bit code, only 1 bit is being inserted in this. As a result, the frame size is not going to be increased much. So that is why this is preferred over the previous method. Okay, so simple example is, suppose I want to send, this is the data. How even this particular, so after 5 ones a 0 is inserted is only if consecutive ones are appeared in the data part, not in the flag byte. So which is being used as indication for end of the frame and beginning of the frame. So there no bit stuffing is used. With the flag byte, no bit stuffing used. Only with running data or payload part or data part, only in that part, if we have consecutive ones, then a 0 is inserted. Suppose if this is the data I want to transmit. This is the data I want to transmit. This is my data. What is my frame? Before this I have the flag byte. After this I have the flag byte. Okay. So now when before sending, so after 5 ones, 1, 2, 3, 4, 5, after 5 ones, there is a 0 inserted at this point. Again, after 5 ones, 1, 2, 3, 4, 5 ones, a 0 is inserted. Again, after 5 ones, a 0 is inserted at this point. Okay. So 3 zeros are being inserted in this. Likewise, 1, 2, 3 zeros are inserted, and this one is this. Next 0, 0, 1, 0 is same as. This is what is being done at the transmitting data link layer. Then after receiving this particular bit stream at the receiving end, so the receiver data link, what it does, after a 5 ones, whatever 0 is there will be removed. Again, after 5 ones, whatever 0 is there will be removed. After 5 ones, the 0 is removed. So this is what the data we are going to get it back. Now here also there is a small problem is, really in our data after 5 ones there may be a 0. In our actual data also, after 5 ones there may be a 0. In that case, again after 5 ones, though 0 is there, so a stuffed bit is being inserted, a stuffed 0 is inserted. Because if 0 is not inserted at that point, though 0 is there, a 0 must be inserted. Otherwise, at the receiving end after 5 ones, whatever 0 is appeared will be treated as the bit is a stuffed bit, so should be removed. That is what the receiver will understand. Okay. So because of that reason, even though original data is having after 5 ones there is a 0 even in the original data, so a stuffed bit is to be added, as the additional 0 must be added at this point. Then after 5 ones, 1 0 will be removed at the receiving place, so original 0 will be retained as it is even after removing. So that is why so bit stuffing method is being used for transmitting the data. So hope everyone is understood about this. Okay. Then, so here how the boundary is being recognized is flag byte. With the help of flag byte, the boundary is being identified. Because in that flag byte, what we have seen, so 7E is the flag byte used. That means 0, 3 ones, 3 ones, 0. So 6 ones are there. So according to what the method we have discussed is, after 5 ones, that 0 must be inserted. But that 0 is inserted only for data part, not the flag byte. So that is why the moment receiver data link layer encounters 0, 6 ones and 0 will be identified that end of the frame, beginning of the next frame. So that is how, so received frame will be identified with boundaries without any problems. Okay, this is what the bit stuffing, byte stuffing, and character count methods are being used. Okay, so only flag bytes are being appeared in this case only at the end of the frames. Even in between, if it is there, but it is being stuffed with 0 after 5 months. Okay, so that is why. So we are not going to get any problem in this. Even the character size is variable, no problem. So that is why these are the advantages of bit stuffing method compared to other one. So and the size of the frame is also not increased much. So that is why people are preferring this.